Welcome. On behalf of Clean Code, I'm me, you are you, and this is population density interview question from Deloitte in pySpark. All right, our problem statement reads as such. Your task is to calculate the population density of cities rounded to the nearest integer and identify the cities with the minimum and maximum densities. Population density should specifically be calculated as population divided by area, and the output should contain city, country, and density. So a couple of things while reading this particular problem statement, this identifies to me as a trench coat problem, meaning we're going to do a lot of little steps and then roll everything up together and present it as one complete solution. So that should lend itself to a bunch of helper functions, and we will address those in the notebook when we break this problem down. However, I do want to draw your attention to here. The output should contain. Now, this is like a very subtle way of saying this is what they want the output to be. So let's be mindful of that. Checking our tables, we see very stock standard, varchar, int, float. Everything looks good from a data types perspective. Don't need to do any manipulations there. If we go ahead and show our table, we can see that area is 0. So we are going to have to deal with zeros, because if we try to divide population divided by 0 area, we'll get a divide by 0 error. All right, so now that we've kind of addressed some of the things, let's jump over into the notebook and start to define our approach on how we're going to take down this problem. All right, now that we've gotten our bearing, let's go ahead and highlight key components of our question so that when we construct our solution, we can make sure we've attacked and addressed all of the key points. So we know we need population density, min, max. Population, the density equation is given, and there is a specific output. And while it is also expressly told us, never a bad idea to write down what columns you're manipulating to generate new columns. So one of the great advantages of pySpark is we can use SQL functions to help us. And primarily, the helper functions I think we're going to need to use is filter, min, max, collect, and there's probably one or two more that we need to do. We'll address those when we get to it. So let's go ahead now and write out the steps we want to take when we're approaching this problem. So step 1, we need to filter zeros. Can't have that. Next, we need to calculate density. Next, we will find min, find the max, and finally output a solution. All right. So I like this format. I think this format kind of helps you, especially while you're practicing, getting ready and preparing for these interviews. Taking the time to really think out your steps really helps and aids in that process. I think we have enough already here to go ahead and attempt to solve our problem. So I will see you back over in the code editor. All right, now that we are here in the code editor, let's go ahead and begin and bring our SQL functions into the environment. We're going to do that by calling SQL functions, and I will be denoting that it is F just to make things easier. And then next, we need to remove rows where density is equal to 0. So we're going to use the filter function to take care of that particular problem. Next, we're going to find the calculation for density. Again, nothing too complex or tricky hidden in the details here. We're just going to make a new column and divide 2 other columns together. Now we're going to use a data frame, a separate data frame, to store our max density. A little bit more complex, but don't worry, at the end of the video, we'll go line by line and explain everything. And if we do it for max, we're also going to do it for min. If you understand one, you understand the other. And then finally, we need to combine our data frames back together and then output that as a data frame to pandas, as explained in the statement. Okay, so this is our answer. Let's go ahead and click run code, make sure everything's working nicely. We do get a nice output. We check the solution. Green arrows all around. We are cooking with gas. All right, this has been Clean Code. This has been solving population density in PySpark. If you'd like a further breakdown of the code, stick around. Otherwise, see you next time. All right, and kicking us off in our first line of code here at line 3, what we're going to be doing here is rewriting the city's population variable we have initialized as the city's population variable, but filtered such that everything that is not equal to 0. So if you think about it, what we're doing is we're saying, hey, we're subsetting our data, and if you're not equal to 0, you get to move on, and we're going to cast away our 0 values. That way we don't have to worry about this population divided by 0 issue. Relatively straightforward. And let's move on to line 5. Right along, let's take a look at line 5. And here we are going to be doing our calculation to find density. So this line here adds a new column of density to the city's population data frame. The density column is calculated by dividing population column divided by area column, and this is going to happen on a row by row basis. We use the function with column to add the column to the data frame, and then we're writing it over. So to explain a little bit more concisely, so we're overwriting city's population again. This time we're writing city's population as city's population. So this part is now this part, and we're saying dot with column, adding a column called density, and we are defining it as city's population data frame population column divided by the city's population data frame area column. All right. Okay, 7 and 10 are basically the same. So let's just explain it once, and then you can flip-flop min and max in your head. So the max density df equals. This line is creating a new data frame. That's what we're doing with the max density df. And it contains rows from city population where the density column is equal to the maximum density. It first calculates the maximum density using the f.max function, and then filters city population to select rows where the density column matches the maximum value. Finally, it selects only the column city, country, and density from the filtered data frame and brings it back. And that's how lines 7 and 10 work. So we actually in 7 and 10 have created 2 separate data frames, each containing half the answer. So we need to put the 2 halves back together, and that's why we're creating another data frame called combined density df. And that's just going to be max density df and then the union with min density df. And that's just going to stack them together. It's not going to overwrite anything. It's not going to go line by line and iterate. And if you can think about it, we actually are fine with duplicates. In this particular example, we need 2 records for each city because we need the max and the min. If you look nicely in the problem statement, it just says density. It does not say, hey, we want a max density and a min density. It just says a density. So there might be some downstream analytics going on. We're going to leave it in. We're going to listen to the problem statement, and we'll just use a union. We'll use a union all, or won't define any other function, and we'll just smoosh the 2 things together. Finally, we're just going to write the combined density df to a pandas data frame. That's just something that the code editor would like to do in order to evaluate our answer. All right, this has been Line by Line After Hours. Hope you had a good one.